In the last section of Chapter 9, 9.8, we're just comparing linear, exponential, and quadratic models. We're not being asked to graph these or write any equations, just be able to identify which one is which. So if you're given an equation of a line we know is y equals mx plus b. And what that means is that the highest exponent is 1 on any of the x terms. So if I have an equation like this, 4x, that has a power of 1, that's my highest power, so this would be linear. If I had 4x squared plus 3x, the highest power is 2, so that is not linear. Okay, the highest power has to be 1. But there might be some tricks. If you're going to need to simplify your equation first, so let's say I gave you something like 3x times x plus 1. Well, you'd need to simplify this because it looks like these both have powers of 1, but if I simplify and distribute, I'm going to get 3x squared plus 3x. Now my highest power is a 2, so that is not linear anymore. Another trick that could happen is if I gave you something like x squared plus 4x minus x squared. Well, while there's x squareds in the problem, if you look at them, x squared minus x squareds are going to cancel. You're going to be left with y equals 4x, so the highest power is a 1, so that is linear. Okay, so try to simplify your equation first because there could be some hidden tricks in there. If you've simplified everything and your highest power is 1, then it's linear. Okay, and the graph of it would just be any kind of straight line. It could go any which way. It could go straight across. It could go on another diagonal. As long as it's a straight line, no curves, it's a linear model. Okay, so now that's all you're going to do is you just have to look at an equation and say if it's linear, or look at a graph and say if it's linear. That's it. I'm not asking you to write any of these. So now let's move on to exponential. Okay, well here's what an exponential model looks like. It's a one-sided curve. Okay, so notice that this curve here in the picture, it only goes up on one side. So that's what an exponential model looks like. The equation, the x is in the exponent, and that's why it's called exponential. So if I had a is just a number. So if I had like 5 to the x, that's exponential. If I had, I could even say negative 4 up to the x minus 3, that's also exponential. Whenever the x is tiny, it has a tiny x. Okay, as soon as x winds up in the power, it's exponential. And the graph of it is just a one-sided curve. It could go the other way too. It could go like this. It could even be upside down. As long as it's only curved on one side, it's exponential. And the last type is quadratic, which is what we've been talking about in the rest of this chapter. But here's where their graphs are just different from the other ones. So a quadratic model is a parabola. So a parabola is just a U shape. It can go an upward facing U or it can be a downward facing U. It doesn't really matter. But your simplified answer is going to have an x squared term in it as the highest power. You can have other ones that are missing, like for example, because it does not have to have 3 terms. Okay, so if I distribute over here, I'll get y equals 2x squared minus 6x. I don't have a c term on the end, but because my highest power is 2, it's still a quadratic equation. Okay, the order can even be messed up. It can be 7 minus 8x squared. Doesn't matter. As long as that highest power is a 2, it's a quadratic model. Okay, so that's it. For 9-8, you're just looking at a graph and saying if it's quadratic, linear, or exponential, or looking at an equation. Remember, with the equations, you want to simplify it first and then see if it's what the highest power is. Okay? And if there's also no power, let's say I had y equals 5. Well, if there's no exponent and I don't have an x in the power up there, I know that the graph of y equals 5, 1, 2, 3, 4, 5, would be a straight line going across, so that's linear as well. Okay? So now you're going to try the worksheet, and if there's any tricky ones, just ask for help. But look, these are the only 3 types you should be naming.